Hey everyone, here we are again with 2.4 from Big Ideas Modeling with Quadratic Functions. We're going to be writing equations of our quadratic functions this time, much like we would do with the linear functions, like in slope-intercept form. We'll review that here in a minute. But first, let's do a little cartoon. Message from the Viking sire. It says, "We've got spirit. Yes, we do. We've got spirit. How about you?" Always a funny little joke there. Cartoon. Alright, so this is one you want to write down on page 41 under your notes. Remember this kind of problem here. It says write an equation in slope-intercept form using the given information. Slope-intercept form, remember, is y equals mx plus b. And so you're going to write this down. Just write this down here. Write that it passes through 4, -1, which is your x and your y number, and your slope is going to be -2, which is the m number. Remember, we did this not that long ago. And so what you're doing is just plugging everything in up here. These three letters go in, and you're going to solve for b. So the first thing starts off with y equals. Well, the y number is -1, so -1 equals. And then the m number is -2, right there. So that's going there. Then -2 is going to get multiplied by x, and x is 4. And then we're going to put plus b at the end of that. So now we just figure out, okay, what this is, do the operation that's right here, just multiply this, it's -8. So now you get -1 equals -8 plus b, and now we just got to add 8 to both sides, and so now these would cancel, and now you're going to get -1 plus 8, which is a +7. So now we can write our equation, y equals -2x plus 7, that's the slope-intercept form of an equation that goes through this point and has this slope. Okay, so essentially we're doing the same idea with the quadratics. They're going to tell us what form it wants it in. We know 3 forms now: vertex form, standard form, and intercept form. Sometimes it's going to show us the graph. Sometimes it's going to give us this right here, some ordered pair points. So let's take a look at what we're doing there. So here's the forms on page 41, right above where I wanted you to write that last problem, the core concept. There's the 2 forms we're going to focus in on this one. We're not going to write anything in standard form. We're going to just write them in vertex form and intercept form. It is a whole lot easier this way. So we are going to be basically solving for A in this one. We're going to know everything except the A. A is the letter I highlighted there. We want to solve for that one. We're going to know on vertex form, the vertex, which would be the h and the k numbers. We'll plug those in. And we're also going to know another ordered pair point, which we'll know as an x and a y point. In the intercept form, we're going to know the p and the q numbers, which are the x-intercepts, where it crosses the x-axis. And we're going to know another point as well. The x and y is going to be maybe even the vertex point possibly could be that. And we'll plug that in to find out the intercept form. Okay, so on page 42, 1 through 4, it says write an equation in vertex form. So here we're given the parabolas on the graphs. We're trying to write it in vertex form, which is this form here where we can see A, H, and K. Remember, X and Y are going to always be the letters in your answer, but your numbers are going to fill in for A, H, and K. So starting off with our vertex, we know our vertex down here is at the bottom. It would be the minimum value, which would be -2. But our H is 2 and our K is -2 on that one. And there's another point right up here where you can see 4 and 6. So right there, we can use those as our x and our y. So we're going to start plugging everything in that we know from this. Well, we'll start the first off just by plugging in the vertex here. So if you just plug in the vertex, that would be y equals the a, and then parenthesis x minus 2, okay, because it's going to be 2 going inside here. It looks like it's going to be the opposite always, right? So whenever you take your h number, it's +2 here, but it goes in. Now it looks like it's -2. Because it's always x minus whatever the h number is. And then it's going to be -2 in the back, which is where the k number is. So now we just need to figure out what the a number is going to be. So we have to solve for a somehow to be able to plug in and substitute in an a number. And once we do that, we'll have our answer, our equation for this parabola. So that's where we're going to use the 4 and 6 point here. The x and the y, we're going to plug them in for x and y. That leaves an equation just with the letter a. So we start off with 6 equals a, and then in the parentheses it's going to be 4 minus 2, x is 4 there, with the square, we can't forget the square, and then minus 2. So what we need to do is take this and simplify this whole part right here, starting with the parenthesis. Okay, so now we're going to figure this out by doing 4 minus 2, which is 2 inside here. Then we got to square that number. 2 squared is 4. That leaves this whole thing as a 4a. So 6 equals 4a minus 2. We will now just solve that little equation, add 2 to both sides. So 6 plus 2 is going to give us 8. So 8 is equal to 4a, and then just divide both sides by 4. So our a is 2. So we're going to replace the a that's right here with the number 2, and there will be our answer. I put it up on top here. Y equals 2 times x minus 2 squared minus 2. That's in our vertex form. Go ahead and pause the video now and try doing number 2. See if you can get the answer. Alright, so hopefully you got an answer for this one. You wrote the equation down, and you're just going to check your answer to see if you got it right. So we know our h and k is going to be 0, 3. Our x and our y numbers are going to be 2 and 1. And so we just start plugging things in. We can plug the h and k in first. So h is 0, so x minus 0 inside the parenthesis. And then the k is 3, so it's plus 3 in the back. So we just got to figure out now what the number is going to be in front of this parenthesis where the a is. So we're going to plug in 2 and 1 for our x and our y numbers in there. So it's going to start off with 1 equals the a, and then 2 minus 0. That's our x number in there, plus the 3. So 2 minus 0 is 2, and then we'll do 2 squared, which is 4. We're going to get 4a again for this part here. So 4a plus 3 on this side. So 1 equals 4a plus 3. Solve that little equation now by subtracting 3 from both sides first. That gives us negative 2 is equal to 4a, or 4a is equal to negative 2. Either way is fine. Just now you need to know you're going to divide by 4. Divide by the number in front of a. So negative 2 divided by 4 is negative 1/2. So that's the number we're going to replace the a with. So we're going to say y equals right up here, negative 1/2. But notice I didn't put the parenthesis because it had x minus 0 in the parenthesis. And x minus 0 is still x. So we can just say x squared. It's a simpler way to write out the equation. So make sure you don't leave it as an x minus 0. That's not the way you usually will see it. And then the plus 3 is in the back still. Okay, on 3 and 4, it says we're going to still be using in vertex form. So let me write this up here on this screen. So again, y equals a and parenthesis x minus h squared plus the k. We're going to underline the ones that we need to fill in for numbers. Well, we do know the numbers for the vertex right over here. That's our h and k. This will be our x and our y numbers. So h is negative 1, k is negative 8. We can already fill those numbers in, but we still need to figure out what the a is. That's where the x and the y will come in to help us. And so as we start to plug everything in, we're going to start off with the y number, 0 first. So y number first equals a. And then in parentheses, the x number, negative 3 is the x number, and it's minus the h number. Now h is a negative, so it makes it a double negative here. So that will eventually turn, we want to turn that into a positive then. So it really will be negative 3 plus 1. And when you're actually writing your answer out, you're going to say x plus 1 in the parentheses. Our negative 8 back here from the k number. K is negative 8, so we'll put minus 8 at the back. Now inside here, we're going to just take 1 away from negative 3. That's negative 2 that we have to square. So negative 2 times negative 2 is positive 4. So again, this whole thing becomes 4a. And it's going to be 0 equals 4a minus 8. And then just going to add 8 to both sides to get 8 equals 4a. Divide both sides by 4, and a is equal to 2. So that's what we're going to now put in for our a. So we're going to fill in 2 for a. It's going to be going in as a positive now. So a double negative will be x plus 1, and then the minus 8 at the back. So here's our answer. Y equals 2, and then x plus 1 in the parenthesis with the square, minus 8. Go ahead and pause the video and try to do number 4. See if you can get the equation for 4. Okay, so hopefully you have your answer. You just want to check your answer now to see if you're correct. So we're going to plug everything in. Again, this is going to be our x and our y point. Here is our h and our k points right there. So we know to plug them in just like we did on number 3. Starting with the y number, right? It's going to say y equals. So it's going to be 7 equals. And then the a number, in parentheses, it's going to be x minus h. So it's negative 4 minus negative 2. Negative 4 minus negative 2. So we have another double negative to turn into a positive there on that one. So it's going to be negative 4 plus 2 inside. Don't forget the square on the parenthesis. And then plus 5. And so inside here it's going to be negative 2, and negative 2 squared again is positive 4. We've been getting positive 4a this whole entire time. It's It's not always going to work out that way, but it just has so far. So 7 equals 4a plus 5, and solve the little equation by subtracting 5 from both sides. 7 minus 5 is going to give us 2 equal to 4a. Divide by the 4, it's in front of a. So that's 2 over 4. 2/4 reduces to a 1/2. So a is a 1/2 number. So we just got to fill in 1/2 for a. Our -2 is going to make this x plus 2, and then this is going to be a positive 5 in the back. So here's our answer. Y equals 1/2 x minus 2 squared plus the 5. All right, so a quick little joke of the day. What do you call a shoe made from a banana? What do you call a shoe made from a banana? Well, of course, that's going to be a slipper. A slipper. I would not want that slipper myself. That sounds kind of gross to have a banana as a slipper. Okay, so for 5 and 6, actually 5 through 8, they want us to write the parabola in intercept form. So that's the form we're going to use this time. And remember what the intercept form is. That's back on your core concept to remind you there. Y equals a. It always starts off with y equals a on all of the forms for quadratics. But then this one has 2 parentheses, separates the x into 2 places, x minus p, x minus q. So you're not going to see a square on this time. You're seeing the x kind of split apart into 2 x's. And so if we need to see that the p and the q are the x-intercepts, which on the graphs here you can see the x-intercepts where it crosses the x-axis. Here at -4 and at +6, that's going to be your p and q. It does show us the vertex, but instead of saying this is h and k, because we don't have any h and k letters in here, we have an x and a y. So we're just going to use this vertex as the x and the y numbers to plug in. So we start plugging everything in, starting just even with just these two here numbers. So y equals the a in the first parenthesis where p goes. It's -4, so it becomes +4, right? As you plug it in, it's a double negative. So x plus 4. This one's +6 for q, so it goes in as its opposite, x minus 6. So remember, these are always going to go in kind of as their opposites. And then we want to plug in our 1 and our 25 for the x and the y. So it starts off with 25 equals the a. And then in the first parenthesis, it's going to be 1 plus 4. In the second parenthesis, 1 minus 6. And then we're just going to simplify each of these parentheses, multiply the 3 together there. So it starts out with 25 equals a, 1 plus 4 would be 5, and 1 minus 6 is -5. So as you multiply a times 5 times -5, that's -25. So 25 is equal to -25a. Divide by -25 on both sides to solve for a, and a is just going to be -1. So now we know that we're going to put a -1 in front of this one. That's this green equation here. Already has the p and the q in them. We just need to replace the a with -1. And we don't actually need to write the 1, we just need to write the negative sign. So here's how it's probably best written out is y equals negative, and then the 2 parentheses, x plus 4, x minus 6. And there's your intercept form. So go ahead and pause the video, try number 6. Do your best on that one, try to get that intercept form equation. Okay, so here we go with number 6. Now I would have changed these fractions into decimals myself. So that would make these our p and our q numbers, -4, -3. Our first thing you can do is write those into your parentheses. So y equals the a, and then x minus the -4 will actually be a double negative there. X minus -3 is another double negative. So these both become positives. And then we're going to use these numbers as it's the vertex number, but we're going to use them as our x and our y numbers. And I'm going to make that into -3.5, and this one into -0.25. So it might be easier to work with the decimals than with the fractions. If you didn't do that, that's still okay. You could still work it out with fractions. So y on this one is the -0.25. And then we say a, and then it's going to be, instead of x, we're going to put the -3.5 plus the 4, and then -3.5 plus the 3. And then we just reduce what's inside these 2 parentheses, do the parenthesis part first. So -0.25 equals a. If I take this -3.5 away from the 4, which is bigger, that's leaving me with a positive number inside that first parenthesis. It's going to be positive 0.5. This one I'm going to take 3 away from -3.5, leaving me with a negative number, -0.5. And now multiply these 3 together. So a times 0.5 times -0.5 would make -0.25a. So if we were to divide by negative 0.25a, well, it's exactly the same thing, and anything over itself is always equal to 1. So a is equal to 1 on this problem. So that means if I plug in 1 for here, we actually don't need to write 1. I don't need to write anything for a, in fact. I'm just going to put y equals these two parentheses for my answer. And so that's what our answer is. Y equals the x plus 4 times the x plus 3, and that's our intercept form on this one. It actually has the same shape as the parent function, even though it's kind of hard to see that because the vertex was these fractions here. So that's probably why it was challenging to see that it was the same shape as the parent function on that one. Okay, so for 7 and 8, it's giving us the information, doesn't show us the graph. It tells us what the x-intercepts are, negative 5 and 8. So that would be our P and our Q numbers. So here's that form again. Let's just write that. I want to write that there. You probably already have it, but I want to have that in front of us as we're going through this. So we need to know our P and Q numbers, which are the negative 5 and the 8. That's the P and Q, and that means at this point that it passes through, it doesn't say that it's the vertex. It doesn't matter. It's just an x and a y point. That's our x and y points that are going to plug in. So as we start plugging things in, we can do it with just the intercepts first. So we know that that's part of the equation already. So y equals the a, and then x plus 5. Since p is negative 5 as it goes in, it's going to change signs to plus 5. Q is positive 8. It changes signs to minus 8. So x minus 8 there. And now we're going to plug in 1 for x and 84 for y. So we do that. It's going to be 84 equals a, and we're going to solve for a now. So it's going to be 1 plus 5, and then a 1 minus 8. And then just work out each individual parenthesis. So that's going to be 84 equals a, and then 1 plus 5 is going to give us 6. 1 minus 8 is negative 7. So these three multiplied together, a times 6 times negative 7 would be negative 42a. So 84 is equal to negative 42a, and divide by negative 42. And 84 divided by negative 42 is exactly negative 2. So a equals negative 2. So now we just need to plug in negative 2 for a right here, and we're having our answer. So y equals negative 2, and then the two parentheses, x minus 5, x minus 8. All right, go ahead and pause the video again. Try number 8 and do this one. Okay, hopefully you've got an answer and have an equation for number 8. Our x-intercepts are 7 and 10. That's your P and Q numbers. Passes through these x and y numbers here, so that's the x and y numbers we're going to use. So as we start to plug things in, we'll start with y equals a, and then our first parenthesis is x minus 7, because it's going to be positive here as a P number, but as it goes in, it looks like it's now negative. X minus 7, and then it's x minus 10, because again, 10 is positive here, so it goes in kind of as its opposite. And now we're going to plug in negative 2 for x inside the parentheses and 27 over here where the y is. So 27 equals a. And then negative 2 minus 7 and negative 2 minus 10. And then work each of these out here. So this is negative 9. So we're going to start off with 27 equals a times negative 9 times negative 12. That's the negative 2 minus 10. And now all of this is going to be positive. 9 times 12 is 108. So we're going to see 27 is equal to 108a, and divide by 108. 27 divided by 108, so 27 goes into 108. Well, it goes into itself once, so there's going to be a 1 on the top, and it goes into 108 exactly 4 times, so the fraction is 1/4. So you got to be careful and not think, well, the answer is going to be 4. It's not. It's because the smaller number is on top, so it's going to stay a fraction. So we just reduce this fraction now, 27 over 108, to a fraction of 1/4. And now we can replace the a number right here with a 1/4. So there's our answer. Y equals 1/4, and then the two parentheses, x minus 7 and x minus 8. All right, we just have a few more problems to go, and then we'll be done with this lesson. Okay, on page 43, we see our last 3 problems here. It says to analyze the differences in the outputs to determine whether the data here is going to give you a linear, quadratic, or neither. So is the data linear data, which would be just a straight line? If we were to graph these points, would they be exactly a straight line? Or is the data a straight line? Or would it be a quadratic function? Would it be more of a U-shape? Or is it neither one? So if it's linear or quadratic, write an equation that fits the data. So first of all, I think we're not going to write an equation for that. I'm not going to spend more time on that. We could do that, but I might talk about that at the end. But let's just first figure out, is it linear, quadratic, or neither? That's what I really want to focus on to be able to understand which one is which. So it says to analyze the differences. Well, the differences would be right here. There are differences in the y's. Obviously, the x's are all going to be kind of the same here. They're going to be all the same difference. So this one's going up by 1s, this one's going up by 3s, this one's also going up by 1s. But the differences are always in the y's here. So you want to look at the differences of the y's. Your first differences, the first time you look at the differences, it will check for linear. If they are all the same, if your first differences are all the same, then that would be a linear function. So write this down over here next to this. First differences checks for linear. The second differences, so once you figure out the differences of this and they're not the same, then you can do a second difference and check the differences of those, and that would check for quadratic. If those are the same, if the second differences are the same, then that's a quadratic. So let's start with number 9 here and look at the differences between here. Now they are going down, so it's like a negative difference. So first differences here, from 424 to 416, that's a minus 8. You're subtracting 8 for that. And then from 416 to 376, you're subtracting 40. And then to go again, 376 to 304, you're subtracting 72. Then 304 to 200, you're subtracting 104. And from 200 to 64, you're subtracting 136. So obviously those are not the same number, so we know this is not a linear function. So now we're going to check second differences, which means we're going to take these numbers now that we have, the negative 8. That's why I kept going to the end, because we need to always go to the end for the first differences, so that way we can check second differences if they're not the same. So now we're going to check second differences and see if they're the same. So negative 8 and the negative 40, the difference there of that is negative 32. So negative 32 is the difference between those. From negative 40 to negative 72, it's also negative 32. And negative 72 to negative 104 is negative 32. And the last ones there are also a difference of negative 32. So since all of those are the same, your second differences are the same number, then we can identify that as a quadratic function. All right, try number 10. Start with the first differences. First difference is from 36 to 30. We're also going down here as well. So it's going to be minus 6 to start with. Then 30 to 24, it's also subtracting 6. 24 to 18 is minus 6. 18 to 12 is minus 6. 12 to 6 is minus 6. Your first differences are all exactly the same. So that means that this one can be identified as a linear function. So that one's linear because your first differences are all the same. Number 11, so now we'll take a look at these numbers. These ones are going up here on this one. So our first difference is from 5 to 15, that's going up by 10. 15 to 45 is going up by 30. 45 to 135 is 90. And then 135 to 405 is going up by 270. And then the last one is going up by 810. So obviously this is not a linear function. So now we'd want to check second differences to see, is it a quadratic function? So from 10 to 30, we're going up by 20. 30 to 90, we're going up by 60. So right off the bat there, I don't need to go any further. Since these are not the same number, I know it's not quadratic either. So on this one, we're going to say the answer is neither. It's not linear, it's not quadratic, so we would say neither for this one. Now, if we were to write an equation that fits the data, what we would want to do here is, since obviously the linear one on this second one is going to be a y equals mx plus b. We'd need to know kind of the form of it. So y equals mx plus b. This one here, we'd want to kind of figure out, okay, what would be maybe the vertex out of that. I'm not going to spend time doing that on these ones, but that's what we could do. We could go ahead and try to figure out that from that the linear would obviously be a little easier than the quadratic. We wouldn't do anything with this one because it's neither. But we could definitely do the linear one pretty well. We could see here's 36, that would be our y-intercept. And we know that our slope is going to be negative 6 because that's the common ratio number. So this number right here is going to end up being our y equals negative 6. And you can just put that maybe down here for this one. We could say y equals negative 6 for this one. At least do the linear one. Negative 6x, that's the slope number, is your common ratio. And then this would be our plus 36, because whenever X is 0, that's your y-intercept, so it's plus 36 on that one. So there's an equation for the linear. The quadratic, we could try and spend some time to do that one, but that's a little bit harder. So this will conclude our lesson now from 2.4. You want to go on to the assignment for that, and then I'll see you on the next lesson.